Greetings, this is Charles Darwin again, and I'm going to introduce you to a friend of mine, Thumbelina. Here's a couple of books about Thumbelina. Here's Thumbelina, a young woman who's so small that she can ride on the back of a swallow. Okay? And here's another one, Thumbelina, who is so small that she can hide inside of a tulip. Now, these are very fun kids' books. These are books that we have borrowed from the local library for my granddaughter, whom you've seen on other videos in the series. Anyway, just how big or how small could a creature be? Well, of course, some of them can be very small, viruses. Some of them can be very large, like whales. But what sort of physical limitations are there for the size of an organism? Life must fit within physical constraints. There's a lot of imagination about the different forms that life can take, but there are limits set by the structure of atoms and the laws of physics as to how big or how small an organism could be. Now, bacteria can be very small, viruses can be very small, but how small could a human be? A human as an example of a vertebrate. Now, there are some vertebrates who are very small. For instance, there is a kind of frog, I forgot to look up to see which kind it was, and I don't remember the exact dimensions, but it was on, in the photograph, on a dime. And I don't mean hanging over the dime, I mean it was completely on the dime. So, vertebrates can be very small. What about human beings? Well, if you have a human being, and we have 70 trillion cells, would that human being have 70 trillion very, very tiny cells? Would such cells be able to operate? Well, perhaps a very small human being would not need 70 trillion cells. But all of the organs would have to be there, the tissues would have to be there, the physiological functions would still have to take place. Now, that tiny frog shows that the physiological functions can in fact occur. But there's something that human beings have that tiny frogs do not have, and that is intelligence. And so it could be that Thumbelina, if she were this small, would be able to fly around. If she could exist like that frog, she could fly around on the back of a swallow. But she would have a brain that is so small that she would not be able to understand what was happening. She wouldn't be able to enjoy it. She would not realize, I'm on the back of a swallow and flying around. And so there are limits to the sizes that organisms can be. Now, in the old days, before our modern understanding of genetics, some scientists thought that there were homunculi that were inside of sperm. Little tiny people inside of sperm. And inside of that homunculus, there were sperm, which had homunculi inside them, which had sperm with homunculi inside of them, and so on. And that was actually believable. Sounds ridiculous to us today, but that's because now we know atoms. You see, atoms are very small, but they have a definite size to them, therefore molecules, therefore cells, therefore tissues, therefore organs, therefore organisms have a certain minimum size because of the size of atoms. So there are limits to how small an organism could be. Sorry, Thumbelina, but if you were this small, you would not understand what I'm saying to you. How large can an organism be? This particular weekend, I don't follow the movies very much, but I understand that this weekend, or maybe it's next weekend coming up, there's going to be a King Kong versus Godzilla movie. Okay, so for 50, 70, 80 years, there's been movies about King Kong and about Godzilla, and I guess somebody finally thought, why don't we put them together? That's going to be the biggest grossing movie of all time. Maybe it is. I don't know. But could such creatures exist? Well, when you consider how large an organism could be, if it is an organism, a biped that walks on 2 legs, or even a quadruped walking on 4 legs, then if you get to very large sizes, like the size of the Empire State Building, for instance, then you would have the weight increasing by the cubic factor, whereas the strength of the legs would only increase by the cross-sectional area, which is square. Therefore, if an organism is twice as big in linear terms, its legs are going to be 4 times as strong, but its weight is going to be 8 times as great. At some point, it's going to be impossible to hold up all of that weight. Therefore, organisms as large as Godzilla or King Kong could not exist, right? Because they wouldn't be able to hold themselves up. but they do exist. It's just that they don't exist walking around. They don't exist in air, which has almost no buoyant force. But in the water, whales. Whales can be absolutely huge, but their weight is supported by the buoyant force of the water. My point here is that by introducing my friend Thumbelina to you is that there are limits, small limits and large limits to the size that organisms can be. Therefore, the laws of nature and of chemistry set limits to what we can imagine, and perhaps what life could be like on other planets, if there is any such thing as life on other planets. And so, this is the thought that I want to leave you with. This is Charles Darwin. Tally ho, and amen.